And we're going to know okay. So first of all, we'll go ahead and solve and get the future value.
12,479.
Okay, 10,800 is what is actually going to be in there at the end of the year. But what they're asking for is what must the nominal interest rates be on the second and third options to make all the investments earn the same yield. Okay, so let's go ahead and take a look at the second and third option. Oops. So the second one is quarterly. Everything else is basically the same, except the answer is going to be different. And then the third option, monthly. Work those out. All right, so what we're seeing here is, once again, kind of the effect of the compounding interest rate. And so you see in the first instance that the amount of interest being generated off of $10,000 is basically $800. With quarterly compounding, you're getting $824.32 worth of interest. And then with monthly compounding, you're getting $829.99. Now, but what the question is asking is, what must the nominal or the stated interest rates be on the second and third options to make all of the investments earn the same yield? So what they're actually saying is, we want all of them to have the same yield, or in other words, earn 10,800. What would the effective rate have to be on this, and what would it have to be on that? So the way we can do that, very simply, is we can put in the 10,800 under this one as the future value, and then solve for the interest rate. Do the same thing over here. 10,800 and solve for the interest rate. Now, assuming you still have it like set up for monthly compounding, you end up here 7.72%. Okay? So what they're saying is the equivalent of an 8% annual rate is the same as a 7.72% quarter or monthly rate.
How did you, sorry, I didn't get how you got, like, how did you get that 7.72?
All I did was simply,
Divide it?
no, I simply replaced the 10,829.99 with
Okay.
10,800 as your future value, and then solve for the interest rate.
And then when I press it, I get 8.
Well, that's because you still have it in as one payment per year.
Ah, okay.
And then for the one that's 4 payments per year, let's do that one real quick.
So if I do 12, this, and then shift this, and then I can do 10,800 future value, and then that, it says error, or doing something wrong. So if I do 12.
You should get 7.77.
I received my grades.
I do 12, this.
Okay? And if you're getting an error message, it's because you put both numbers in as positives.
I put both numbers as what?
Somebody said they got an error message.
Yeah, I did.
And if you got an error message, the reason you got an error message is you probably put the 10,000 present value as a positive number, not a negative number. Okay? Because it's basically, there's no solution whenever you do that.
So the,
Okay. All right. What's the next one you want to do?
I received 2.
Okay. No other suggestions?
31.
31.
This one?
Okay. So, this lease, let's take a look at this. All right. Requires you to pay, excuse me, $40,000 at the end of the first year, and then it escalates by 4% a year for the remaining 4 years. Okay. So, one of the most common things with a lot of commercial leases is you have what are called escalation clauses. And this is just simply a way for the owner of the property to ensure that, you know, the revenue being generated off the property is commensurate with any sort of, you know, growth rate of the economy, and you know, giving them obviously a little bit of extra money each year. So in this particular instance, what you're basically having to do is you're starting with a base rate of $40,000, and then you're saying every single year we're going to increase that by 4% a year. Okay? I wish I could tell you there was like a super simple, easy way to do this on the calculator. There isn't. Okay? This is one of those you're going to have to kind of do by hand. Now on Excel, it's a little bit easier. But what I would do is as follows. I would just simply put the 40,000 on the next year, and then multiply it by itself plus the 0.04. Okay, so 1.04. So that multiplies it by itself and then adds in the 4%. And so you're going to get 41,600, okay, for year 2. Okay, everybody kosher with that? Yes? Okay, you're going to follow that same procedure, except now you're starting with the 41,600, and it's escalating by the 4%. If you left it in your calculator, you don't have to clear everything out and start all over. You can just kind of continue.
Dr. Warser? Dr. Warser. Dr. Forgy.
Yeah, I don't respond to his name.
Yeah.
I respond to my name.
Last 8 weeks were.
It's 4,000 annual. That's why 1.04.
Oh. The 1.04 is.
Yeah, it's 4%.
Is the growth rate each year.
4% divided by 4 years.
Okay? So if you apply that 4% growth rate each year, basically for the remaining 4 years, what you're going to see is obviously the lease rate jumps from $40,000 for a year all the way to $46,794.34. Okay, does that make sense? That part of it.
Yeah.
Okay, all right. Because all you're doing, once again, is you're just simply multiplying it by itself, which is 1, and then you're adding to that 1 the 4% growth rate. That's where the 1.04 comes from. Okay. Now, the problem says, okay, what's the present value of all of this? And so we're going to put this in as a series of cash flows. Okay, so this is something brand new that we haven't done yet. All right. So, first of all, go ahead, once again, 1 payment per year. All right. Now, what we're going to do is we're going to use the cash flow function of the calculator. All right. For our initial cash flow at time period 0, we're going to have 0 because nothing is occurring there. The first payment is not received until 1 year out. Okay. So the calculator needs to know that's going to be our first cash flow. Now, on your calculator, third key over, third key down, has CF sub J, cash flow sub J. Now what that means is that basically you're going to put in period cash flows or dollar amounts each year or each month, depending on what the problem is, and then ultimately the calculator will keep track of those. And the beauty of this, of the cash flow versus the payment function, is the payment function assumes constant fixed cash flows. We're going to repeat that. The payment function assumes constant fixed cash flows, whereas the cash flow function allows you to have variable cash flows from 1 year to the next or 1 month to the next. Okay, so that is more realistic. Like for example, you own a property. You know, you may be charging the same amount in rent each month, but expenses could change from 1 month to the next. And so it's very possible at the end of each month and the end of each year, that cash flow is going to be a little bit higher, a little bit lower, a little bit higher, a little bit lower. The cash flow function allows you to put all those in sequence. Okay? So, what you're going to do is you're going to put them in just as we've got them written. 40,000 cash flow, 41,600 as a cash flow, 43,264, 44,994.56, and 46,794.34 as a cash flow. Okay. Now the next piece is that your discount rate is 13%. So you simply put that in as your interest rate. And now what you're going to do is you're simply going to solve for what is the net present value. Okay? Not the present value, but the net present value. And this is underneath the PRC key. Okay? Now, I'm going to go back and explain this in just a second. Right now, let's just go ahead and plug and chug.
You probably.
No, not me.
Probably.
I mean, there's more here. In terms of amount, so more.
Probably added it. CFJ.
Okay, 150,955.
Oh, I thought it said 150.
All right?
Yeah, but just pressing buttons. It's not like a
So let's just do, once again, kind of some simple math on this. All right? All of them are something greater than 40,000. But if we just simply took 40,000 times 5 years, what would that be?
200.
Okay? So 200,000 would be, and then we add in all the extra change, so we probably got another, I don't know, maybe 15 or so $1,000 on top of that with the extra, sort of, well, the amounts above the 40,000. So the point being is, what we're saying is we've got $200,000 plus of actual dollar revenue, and we're discounting that over that 5-year period at 13% discount rate, and that gives us basically a net present value of $150,000. Now, if those numbers had been constant numbers, like in other words, it had been $40,000 a year for 5 years, we could have just simply used the payment function, okay? But because the numbers are different each year, that's the only reason why we have to use this cash flow function and use the net present value function. Does that make sense? Okay, and we're going to be doing more of this later, but just right now, just to kind of, that's your first introduction, if you will, to the idea of net present value. Okay, all right. Next one.
$20?
Number 20.
No thing is.
We did already.
We did?
I believe we did that one, yeah.
25.
I didn't get that one.
We did that one well.
This is a 4.
Oh.
4, 5.
23.
Okay, well, let me do this. Let's just, well,
Mark them off.
mark them off. Okay, so have we done number 1, yes or no?
No.
Yeah, we did.
No. No.
All right, let's go back to mine.
No.
I had it right.
No, you didn't. We didn't do one. We didn't do one.
Okay, I'm going to start circling these. So we did A7, we did A12,
A8.
A21, A25, A37,
Can't sleep in class.
A38, A3, A6, A16, $18 and $11, and $20, 28, 32, and 8,
About
24,
That's what I missed, right?
2,
No, this is part
31,
two. Annuity. Annuity?
And this one you use the beginning and this one.
Oh, great.
okay, I think that's
Is
it.
it 18?
Okay,
Can we do 33?
yeah, we can do that, we haven't done it. Okay. So just to help you out, and we're just gonna go through, okay, so just you wanna circle the ones that we have done. We've done 2, 3, 6, 7, 8, 11, 12, 16, 18, 20, 21, 24, 25, 28, 31, 32, 37, 38,
And
Okay.
5. And 5.
and 5.
And A5?
Yep.
Yeah. What was the first one?
Okay, so what was the one, I'm sorry.
33.
33.
I don't have 20 either.
Okay. All right, so both of these are annual. So for lease A, we've got payments of $55,000 for 5 years. Discount rate is 12%. Okay, for lease B, the lease payment is $45,000, 5 years, 12%. Oops. Okay, now, this, just remember, we're doing this from whose perspective? We're doing this from the tenant's perspective or the landlord's perspective?
I think you're doing it from the tenant's perspective. Because you're gonna have to spend the
No, it
30.
says, which leases should you accept?
So it's probably income as a landlord, which offer you will accept, no? Without, am I wrong?
Well, if you're spending $35,000 in tenant improvements, then you're a landlord.
Yeah, I would go with you're a landlord. Okay, so if that's the case, those are cash inflows. This is where it matters, okay? But under the second scenario, you're gonna have to spend $35,000, which is gonna be a cash outflow to you as the landlord, all right? And then now we need to solve for, in this case, we can do this a couple of ways. Okay, we can go ahead and still solve for present value. Let's do that first. All right. Okay, so the present value of the income off of the first lease, 198, 262, 69. Okay, now then, let's ignore the 35,000 for a second, and let's go ahead and calculate the present value of the second lease. And we get 162, 214, 92. All right, and so if the assumption is that we're going to have to pay, as the owner of the property, an additional $35,000, then what does that mean to us? This is the value, in essence, of the income stream, is 162,000, but potentially, if we've got to pay an extra 35 grand,
So you gotta subtract that 35 grand from 162.
yeah. Which makes me believe that they're actually looking at this from the tenant's perspective because the numbers are so far away from each other. If we're trying to look at it from that perspective. So we'll do it this way.
What?
If it is indeed the landlord's perspective, it's 127,000. So under those circumstances, we would very clearly accept A. Okay? Now, if it were the tenant's perspective, how does that change things?
Well, no.
You add 35,000 to 162.
You would add 35,000 to 162.
That's very close.
And you end up with 197, 214. And so under that circumstance, the tenant would probably accept this one because it's slightly less expensive than the other option, except for the fact that they've got to come up with 35,000 out of pocket. Just a question of how you want to look at it. Okay? All right, moving on. Next one.
I heard 34.
All right. Okay, all of of this is annual. All right, and nine payments for 9 years, apparently. We'll draw out 100,000. And it's earning 9% interest.
Future
Okay,
value.
so it's a two-parter. All right. So the first part is the actual retirement, which,
What?
yeah. Okay, let's show this on a timeline here. Okay, for years 0 through 10, you are going to be making deposits into this of a certain dollar amount each of those years. But then you're going to be withdrawing here 100,000 each year up through basically year 19. Does that make sense? So it's kind of a two-part problem. So the first part is we're solving how much do we need to have in the account here, okay? So in order to do that, $5.99, $5.24, 69. Okay, and then the second part of the problem is going to be basically taking that, the 529, I'm sorry, 599, 524, 69, putting that in as future value, and then solving for equal annual payments you must put into the fund. Okay, always 9%, yep. And that's for 10 years. And solve for payment. Okay. So 599, 524, 69, future value, 9% interest rate, 10 years, solve for payment. So the annual payment that you've got to deposit is $39,460.77. So that would be basically that number there. Okay? Make sense? All right. Any others?
What's left?
We do 35. Go piggybacking off that.
Okay. All right, there, the only difference, it's actually a simple one, is you're just going to change this interest rate from 9% to 6%, and then resolve for payment. And so you're going to get $45,484.71. Okay? All right. All right, any others? We still got a few left.
40?
Number 40.
With this questions like this, it's better to do it two separate
Yes.
kind of equations.
Yep. So let's just draw a timeline for this one. Okay. You've deposited 10,000 into the account here. it's earning 8%, and you're gonna do that 1, 2, 3, 4, 5 years. At the end of the 5th year, you're gonna obviously take and withdraw 8,000 and put it into an account earning 9%. Your original account continues to make 8%. How much will you have in the two accounts at the end of the 9th year? All right, so the way that I would sort of set this up, first of all, let's take the $10,000, put that in as our present value at 8% for 5 years. Find the future value of that. You should get 14,693.28. We subtract out 8,000 from that. We get 6693.28. Okay. So now what we've got is we have 8,000 that's going to be invested for 6, 7, 8, 9, 4 years at 9%. We're going to find the future value for that, and then we're going to have the 6,693.28 invested for 4 more years at the 8%. Solve for future value for that, add those two together, and then we've got our answer.
Oh.
Okay. So the total, 20,398.78. Okay. Make sense? All right. Next one.
39.
Okay, so with this one, once again, annual compounding. So we're going to start off with 5,000 is in the account as our present value. We want to accumulate 45,000 as our future value after 10 years, and 8% interest. And we are simply going to be solving for what is the payment that we need to make each of the next 10 years to accomplish that goal. Okay. Okay, so we should end up with 23, 61, 18. Okay. Okay, any others? Still got 15 minutes.
36.
Okay.
You got minus 2,360.
Yeah, I'm getting sloppy, but
Just
it's-
making sure.
Yeah,
All right.
it's all right, trust me.
Just making sure, that's all.
Okay. All right, this one, 7% is the interest rate. And once again, another double the, so we put in, I don't know, $100 present value, $200 future value, and we are simply looking for the amount of time that it's going to take, so we're going to be solving for n. So you should get 10.24 years. Okay? All right, any others?
So for that number, you put plus minus after 100 because
Because there, you're having to make, you're making the assumption that you're spending $100, or you're depositing $100, or you're investing $100, therefore it's a cash outflow, and then the $200 is going to be a cash inflow, or basically a return of capital. If you put both of them in as positive numbers, the calculator looks at that, that's like money falling from the sky, because there's no basis to calculate a return, because it's all positive. You've got to have a cash outflow in order to have a cash inflow.
We'll do 23.
23.
we did 23. I have 23.
No, we didn't.
No, we'll do it quick.
Go do it again.
Okay. 23, this is yearly, so $5,000 is the payment. 10 years, 14%. And we're just going to be solving for what is present value. $26,080, 5758. Okay? All right, any others?
14.
Okay. So, month, 12 monthly payments. $1,000 as the payment, and we're going to go ahead and set this up as begin end mode. And 5 years. Solve for present value to start with. Oh, I need to put the interest rate. 12%. Okay. And the other part of that is a sublease, which we'll talk about here, for 1,800. Sold for present value. Okay. All right. So the way that I would interpret this problem is that you have a tenant, they're paying $1,000 a month for the next 5 years. They determine that there's someone that they can sublease it to for $1,800 a month, okay? So obviously that's an extra $800 a month that the tenant is able to just put in their back pocket. Does that make sense, yes or no?
Yeah.
Okay, so what they're asking for is, well, what is the value, in essence, of that extra $800 a month for the 5 years? Well, by doing what we've just done, all we should have to do is simply take these two numbers, subtract the 45, 404, 59, so the value, if you will, of the leasehold is 36,323.67 is the answer. So in other words, to that tenant, they're pretty much getting 36 grand in terms of the value of that $800 a month for 5 years. Okay? Make sense? All right. What else? 8 more minutes.
What numbers haven't we done yet? 17.
Okay.
There you go.
17 it is. Okay, so the first one is monthly. And for 1 year, $50,000. It's present value, 6%. And then we're looking at it in terms of future value. And then the second piece of this is, oops, sorry, 1 payment per year. For 1 year, for $50,000 at 7%. What is the future value of it? Okay, so let's see what we get. Once again, make sure your calculator's set on back on in mode. Okay. Okay, so I get 53,083.89 over there. $53,500. Okay, so in this case, they are asking you, which option would you prefer? Well, seems pretty logical to me. We're probably going to prefer that one because obviously it generates more in interest or more in interest accumulation. Okay.
Which one do you do?
All right.
The first part?
Anything else?
Did we do 15?
Okay.
No.
Okay, this one's going to be a cash flow. So very similar to the previous setup with the cash flow, 1 payment per year. And in this case, we're going to start with a zero cash flow because, once again, we're starting with the end of year one. So 20,000 is a cash flow. 22,000 is a cash flow. 25,000 is a cash flow. 30,000 is a cash flow, and 32,000 as a cash flow. And do that for 15% interest rate, solve for net present value, let's see what we get. Yep, 83,526. Okay, and 62 cents. All right. Any others?
13.
Okay, once again, this one's going to be annuity due, so begin in mode. $1,500, and this is going to be monthly. $1,500 as our payment. 5 years. 10% discount rate. And simply solve for present value. $71, $186, $37. Yep.
Every time we see the annuity word on an
Annuity
exercise,
due, not in just annuity by itself, but annuity due.
oh, annuity due, we have to use the beginning function.
That is correct.
If we're making a payment over a course of time, and wouldn't this be like an outflow?
Oh, no, you could put it, I mean,
You can
once
do
again,
that.
I'm getting sloppy, so yes, it should be technically, I'm just trying to
Okay.
minimize the keystrokes. Okay, any others? Is that it? Still got 2 minutes.
9?
Number 9?
Yeah, sure. Or 10 actually. Do 10 if we have 2 minutes.
Number 10.
Or both.
Don't make a
Sounds great.
difference.
All right. Okay, so which is it, 9 or 10?
10.
10, okay. Okay, monthly?
So it's 12.
5.75 is our interest rate. 120 is going to be their payment. Okay, and this is 5 years. So we'll be solving for future value to start with. So 8318, 83 is the amount that will be accumulated by the end of the 5-year term. But what they're basically asking for is they're looking for this as their down payment, and so they must have 20% of the house price as a down payment. And then, so this is basically saying what price can they afford the home after saving for 5 years. So this represents what? 20% of the total, yes?
So multiply
So
by
you just simply take this
divide by 80,
and divide it by,
80.80.
20, 0.2.
You want 80% more than that, right?
we want to know what the total,
Yeah, so you have
It's going to be-
20%, you have 20%, you want the other 80, right? Making sense?
Shift. Yeah.
Okay.
No, you do 5.75.
That's the payment. Brain's not working.
all right? Okay, it's officially noon. All right, you have, for those of you that are coming back at 12:30, you've got 29 minutes. So we'll see you back here at 12:30. Yep,
This lunch will be posted online, right?
the video deal.
Today?
As soon as I can. I mean, I should just try to do it right now.
Do you also come to Tuesday?
Huh?
Do you come to Tuesday?
What's Tuesday?
Lab day?
No.
So this is the class course that we get.
Yep.